Here's problem number 3 from assignment number 6. Intervals of increasing and decreasing. We'll want to look at the first derivative. And when is equal to 0. Let's factor out a 4x. We're left with x squared minus 1. So 4x times x minus 1, x plus 1. So it looks like we're going to get a critical value at x equals 0, at x equals 1, and x equals negative 1. F prime, then break up that number line. And then we ask, well, what do we get? It looks like we're positive, negative, positive, negative. So intervals of increasing is going to be on the interval from negative 1 to 0, and on the interval from 1 to infinity. And decreasing will be on the interval from negative infinity to negative 1, and from 0 to 1. Maximum and minimum values of f. Well, f of negative 1 is going to be a minimum. So that's going to be 1 minus 2 plus 3. It's going to be 4 minus 2, which is 2, is a local min, because f prime of negative 1 equals 0, and f prime goes from negative to positive at x equal negative 1. F of 0, which is equal to 3, is a local max, because f prime of 0 equals 0, and f prime goes from positive to negative at x equals 0. And then lastly, f of 1, which is also equal to 2, is a local minimum, because f prime of 1 is equal to 0, and f prime goes from negative to positive at x equal 1. On to part C. Find the intervals of concavity. Well, we've already found that f prime of x is equal to 4x cubed minus 4x. So f double prime of x is equal to 12x squared minus 4, and we'll want to find out where that's equal to 0. Let's factor a 4 out, and we're left with 3x squared minus 1, and so that ends up being 3x squared minus 1 is equal to 0, 3x squared is equal to 1, squared 1 over 3, x is equal to plus or minus the square root of 1/3. So, on f double prime, we've got negative root 1/3 and positive root 1/3. Looks like this is going to be positive on the extremes and negative in the middle. So therefore we could say it is concave up on the interval from negative infinity to negative root 1/3, and also root 1/3 to infinity, while it is concave down on the interval from negative root 1/3 to positive root 1/3. And now let's put all those pieces together. So what we have is let's double check at -1 and +1, they had a value of 2. At 0, it had a value of 3. It's concave down on this interval and concave up everywhere else. Concave up everywhere else. And so there's my graph.